Swell of the summer hits Hawaii and is bound for California. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 17th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and hit the like button and subscribe and ring the bell. You'll get automatic notifications when we update the forecast. All right, let's get to work. Looking at significant wave heights for the South Pacific Ocean. Right now, not a whole lot is going on. Can't say that that was the case about a week ago, but right now, quiet pattern in control, no seas of interest, and no swell other than the big swell radiating north. Let's get into the details. We're going to look forward first. We're looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a push in the jet to the north, and well, we see one here in the far southeast Pacific, but that's even east of the California swell window. But what that trough would do if it was over here is help create a clockwise flow loft and down at the ocean surface. That's the hallmark of low pressure in the southern hemisphere. And of course, low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, turn into swell. And swell, if it's aimed at you, eventually turns into surf when it hits your beach. All right, so right there's New Zealand, Antarctica, the Ross Ice Shelf roughly in here. We see the southern branch of the jet stream pushing south. The northern branch split apart from it. We have a gap in between the two branches of the jet stream. That just creates high pressure loft and does nothing for creating meaningful swell. Looking out to Monday, the 18th of July, same pattern. If anything, the jet pushes further south into Antarctica. On Tuesday, the 19th of July, pretty much the same thing. So we get into Wednesday. Yes, the jet isn't as far south under New Zealand, but still not really what would be considered a trough. Same thing on the 21st of July. And then as we get into Friday, the 22nd, something that almost looks like a trough starts to develop, not pushing very far to the north, though. The Ross Ice Shelf right about 63 south right here. So the jet isn't really pushing even into free and clear open waters. Saturday, the 23rd, it's just a zonal flow. That is, the jet pushing pretty much west to east, not forming any trough. And then we get into Sunday, the 24th of July, more of the same. So no clear indications of any support for gale development in the upper atmosphere. Let's go take a look down at the ocean surface. And of course, it is winds blowing, interacting with the ocean surface that generates waves. Right now, there is a gale, we'll call it a gale, 35 knot winds aimed off to the northeast. Not very strong. Forecast building as we get into this evening to maybe 40 knots, but then quickly fading. Hardly get it, not in place long enough to get any traction or meaningful interaction with the ocean surface, and really nothing happens. We're just flipping through here. We're out to Wednesday, the 20th of July, still no meaningful fetch. We'll continue on a little bit of gale forecast developing on Thursday, the 21st of July, with 50-knot winds over a tiny area, just barely clear of the Ross Ice Shelf, pushing east. Maybe some seas of interest would get generated, but we really need fetch and the fetch area pushing off to the northeast. We don't see that. A little bit of two tiny spurious gales late on Friday, the 22nd of July. Probably nothing meaningful coming from them. And here we are on Sunday, cut off low, trying to circulate east of New Zealand, generating some minimal fetch. But things, in general, not looking very positive. Let's go look at the effect of those winds on the ocean surface. And here we go, significant wave heights for the South Pacific Ocean. On Monday, a tiny area of 26 to 28 foot seas develop over the South Central Pacific. Maybe good for 14 or 15 second period background swell at best at exposed breaks, about a week or so after that happens. And now we're out into Wednesday and Thursday, the 21st. We know here's this little fetch that develops right off the edge of the Ross Ice Shelf. 34-foot seas being generated, but look, they push off to the east, really not pushing to the north at all. Another tiny little fetch with 32-foot seas on Friday night, early Saturday, the 23rd of July. Probably nothing meaningful from that either. Secondary pulse of it as we get into Sunday. And that's it. So Looking forward for the next week in terms of generating new swell, not a whole lot is forecast, but we know for sure there is something serious in the water. Now we're going to go back in time. Saturday evening, the 9th of July, 0Z Sunday the 10th, a gale started developing. New Zealand right here, southeast of New Zealand, 50-knot winds, almost building to 55 knots over a pretty good area. And look at this, pushing well to the north and northeast, continuing into Sunday morning, that is the 10th of July, and then building more with 50-knot winds into almost Monday, the 11th of July, before it faded out. Classic hallmarks of a large, broad gale with fetch pushing to the north and tracking off to the north. Let's see what effect those winds had on the ocean surface. So initially seas were like 28, 29 feet, quickly building to 36 feet per the model, and then up to 41 feet right here, 41.7 feet, the highest seas. You can see them right about there over this entire domain. That was on Sunday morning, the 10th, building to 44 feet midday Sunday, then fading from about 43 feet Sunday evening, only to rebuild yet again on Monday to 41 feet, looking good, and then fading out. But we know there is significant swell that's already hit Hawaii and it's pushing towards California. The models do not appear to be telling the whole story. Let's do a deep dive. All right, wind data from the ASCAT satellite. We talked about the models, and the models are a projection or the best guess of what a computer thinks is going on at the ocean surface. But there are satellites that are beaming radar down on the ocean surface, telling us various things. The ASCAT satellite used to give us wind speeds. Now, we saw winds were in the 50-knot range per the model, maybe a tiny area to 55 knots. But looking here, the black flag, the black triangle here with the, and it's hard to see, but there are barbs hanging off of some of these. So just a black triangle with a line right there. That's 50-knot winds aimed off to the northeast. But then there's a whole stack of these barbs with either a triangle and a whole line or a triangle and a half line. That's 55 to 60-knot winds over a broad area. The point being, this satellite pass suggests that winds were stronger than what the model thought they were. And we have yet another pass of the same satellite, basically painting the same picture. 50, 55, maybe even some 60-knot winds embedded in there, all on the 10th of July. So winds stronger than what the model suggested. And then we look at altimetry data, the effect of those winds on the ocean surface. And we can see this one pass right here about 4Z. I assume that's on the 11th. So that's late on the night of the 10th. It's hard to read here. 47, 45, 50-foot seas, 50-foot, 48, 49 right there. And then a variety of 46, 48, and maybe higher seas right in this area here. And you can go look at the actual coordinates and map it all out. But this is right where the fetch was. And then we took our own data from the Jason 3 satellite. You can see the satellite tracks right here, overlaid on top of the wave model. Now you notice there aren't a million satellite passes here. It's sort of a game of you're lucky if you get a satellite pass near the core of the fetch. This was at 06Z on Monday the 11th, so the night of the 10th. The core of the fetch, maybe producing 42-foot seas right there. You see the satellite pass went right there, and you see the much broader extent of gray colors scattered over this whole area. What we do is we took an average measurement of the 15 highest consecutive readings, like bump, 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 15 right in a row. Said seas were actually 48.9 feet on average over that area, with a single reading up to 55.8 feet. And you can map it out here. It was at 55 south, so there, and roughly 159, about 160 west. So right about there. So the model said 42-foot seas. In reality, there was 50 to almost 56-foot seas in this area. So the model, at least per this one image, grossly underestimated it. But that wasn't the only measurement. Here is the storm. We're looking at the hindcast wave model. Here's another pass right here. Average measurement, 31.7 with a peak at 35. Seas, you can just eyeball it, were about 30, 31 feet. So that the model was about on track. And then we got another pass out here in the leading edges. Seas were 28.4 feet with one reading at 34 feet, where the model said they were about 27 feet. Okay, that's not too earth-shattering. But here's another one where seas, the seas per the model were, we'll be generous and say 28 feet. The satellite said 34-foot seas with one reading to 44 feet. Then here's the pass we just looked at, 49 feet roughly with 1 to 56 feet. And then I think there was one more, here we go, right here, where seas were supposedly 30 feet. No, they were confirmed at 38.5 feet with one reading to 42.7 feet. The point being, it appears the model, both the wave model and the wind model, grossly underestimated the strength of the storm, which resulted in significantly lower sea heights than what was actually happening. The satellite passes all confirmed winds 55 to 60 knots and seas in the 50-plus foot range for a good duration over a broad area. That means larger than expected swell per the official NOAA estimates are en route. Of course, this swell is hitting and has been hitting Hawaii since yesterday. Just as of this time, it is about 2 or 3 o'clock California time. Primary swell, 4.2 feet at 17.9 seconds from 190 degrees. That's 7.5 feet. One can loosely translate that to Hawaiian. Double that, that's 15 feet. That's probably a bit of an overstatement. We'll say in the 10 to 12 foot range. Here's the spectral density as of this report. Still piles of energy between 20 and 18 seconds. You can see here's the calculated surf height as of the most recent reading. Yeah, like a 7.5 feet. But you see these spikes up to 12 and 13 feet that occurred. This started sometime early this morning, went through about Hawaiian time, about sunrise or so. And certainly there was large surf at sunrise in Hawaii. But slowly it's trickling down into more manageable size. Let's go take a quick look at the spectral data from when the swell was peaking. All right, so we're looking at yesterday. That would be Saturday, about 5 o'clock, 6 o'clock California time. Would that be about 3 o'clock, 2 or 3 o'clock Hawaiian time? At that point in time, here, we'll click away, see if we can get this. There we go. You can see a big peak of energy in the 20, about 19 seconds. And by by sunset, that'd be, we'll say about 3 or 4 Z. There was solid energy hitting, individual energy 3.5, 3.9 feet at 20 seconds, 18 seconds. So pure swell, definitely solid. And then we went through the evening. We'll just run through this real quick. Still, you can see this updates every half hour, the seated buoys. So you can see there's a bit of variability. Well, there's clearly like some bigger probability of conglomeration of sets here around 10Z. That'd be the middle of the night Hawaiian time. And then as we get towards sunrise, a couple of still very solid readings. But then, there you go, big one, 16Z, what is that? That's about 8 or 9 o'clock California time, so 6 a.m. sunrise in Hawaii. Very large powering sets pushing through with long period. And now, as we get later in the day, still solid sets, but starting to trickle down. The point being, there is large swell in the water. It's already hit Hawaii. There were some individual readings at 7 feet at 18.5 seconds. Pure swell at Hawaii. That's 13-foot Hawaiian. But theoretically, you'd say that's 26-foot faces, but there are no waves that large. But it was very thick and very large indeed, probably in the triple overhead range. And that swell is not just focused at Hawaii, it's also focused at California. Solid energy is pushing towards California for the early part of the week. We're not going to get into all the details, but let's suffice it to say, peak period where the peak size in California will be somewhere in about the 18.5 second range. Period will fall back a little bit because there's the extra travel distance. So where Hawaii, most of the energy was at size-wise was at 19 seconds, maybe 19.2. California probably in the 18.4 to 18.6 second range. Look at the tools on Stormsurf. You can figure out pretty easily when it's going to arrive at your favorite break. Anyway, this is not a beginner's swell. This is an experts-only swell. There will be a large number of waves per set, a lot of water moving around. Not the kind of day for soft tops and short boards and fishes and all that stuff. This is going to be big wave boards and big wave surfers only. Don't get in over your head and don't get yourself into trouble. All right, let's move on. So the next question relative to California is wind swell, and how bad or good will there be in terms of wind swell interacting with this large, long period southern hemiswell. So Sunday, right now, winds out of the northwest at 20, maybe 25 knots off of northern California, and less down as you get into central California. Trades for Hawaii at 15, 20 knots. That seems about right. So you get into Monday, winds start fading for California in the 10 knot range for central California early. Trades continue for Hawaii with the swell dropping there. So we get into Tuesday, winds dry even more, wind swell dropping more, and also trades fading for Hawaii. A tropical system pushing west-northwest, really of no interest immediately. Wednesday, winds continue from the northwest at 10, 15, maybe a little bit more, but wind swell pretty minimal relative to California. Trades for the Hawaiian Islands as the swell fades there. And as we get into Thursday, pretty much more of the same thing. This system, because it's pushing off to the east-northeast, I think the name of the system is Estelle, winds peaking at 100 knots, but because of the forward motion off to the west, not a lot of energy pushing up into Southern California. That's probably a good thing not to mar and cross up the long period Southern hemiswell. So get into Friday, more of the same sort of thing, Estelle fading out, winds along the California coast starting to pick up, trades start fading into Hawaii. Saturday, then we start getting into wind swell again. By then, the swell in California, the big southern hemiswell, will be fading out, if not gone, and certainly gone for Hawaii. And then we get into Sunday, again, more of this raw wind swell junky thing starting to develop for California. Estelle gone, trades for the Hawaiian Islands. And just a quick look at temperatures for the PCT, Pacific Crest Trail. This is a Tioga Pass Resort, so Yosemite high country, certainly no snow forecast. The point being the freezing level above 14,000 feet for the next 10 days, so no significant odds for any freezing water while you're backpacking or anything. Pretty much standard summertime backpacking conditions. All right, let's go take a long term. What's going on with the Madden Jullian Oscillation? Of course, the El Nino Southern Oscillation. All right, so first off, we're looking for signs of the active phase of the MJO, the Madden Jullian Oscillation. It is this periodic weather oscillation. There's an active phase and an inactive phase. The active phase on one side of the planet, the inactive phase on the other side. They rotate diametrically opposed to each other from west to east. When the active phase is over the Pacific, it feeds energy to the jet stream, which in turn can feed gale and storm development. It also can reverse trade winds in the West Pacific that can in turn create a Kelvin wave, a ball of warm water that can travel under the equator from the West Pacific to the East Pacific and erupt over the East Pacific. If you get successive active phases of the MJO and successive Kelvin waves, that can help usher in El Nino. Of course, that is not happening right now. We are in a La Nina state, and we are in the inactive phase of the MJO over the Pacific at the very moment. What that also sort of highlights is you can still, the MJO is not the begin-all and end-all of determiners, especially in summer for the southern hemisphere. We're in the inactive phase of the MJO, yet we had a stronger than expected storm that made a large and very powerful swell that is radiating, rippling, propagating across the Pacific as we speak. So the MJO is not the sole determiner. It has more of an influence in the winter months. Anyway, so where are we now? Well, we're looking at data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. We're just looking at the arrows. And the longer the arrow, the stronger the winds. And the winds out of the east, strong in the East Pacific, strong over the Central Pacific, and strong over what we call the Kelvin wave generation area. The far West Pacific, 135 east here to about 170 west here. This box 5 degrees north and south of the equator. This is where, when the active phase is over this area, it can reduce trade winds and do all the magic things we were just talking about. But we see no signs of that at the moment. But that's the average, 5-day average winds. Anomalies, the differences from normal for this time of year. Yeah, these winds are pretty strong in the East Pacific, but not unusually so. Maybe just slightly stronger because the arrows are real tiny here. A little bit stronger out of the east. Moderately stronger over the Central Pacific. And in the Kelvin wave generation area, yeah, moderate plus strength. So still a inactive phase in control. But that said, we got a bottom of a storm and we have swell. So, like I said, that's not everything. All right, so what's the wind pattern the MJO going to do for the next week? Here's what we're looking at. Zonal wind anomalies, the east-west component of the wind. The purples here, you see them in blues, those are easterly anomalies. Consider that the inactive phase of the MJO. The yellows and reds are westerly anomalies, the active phase. Now, this is not the Pacific Ocean. This is the whole planet on one chart. The date line runs right up the middle. The far West Pacific starts at 135 east, okay? And ends, the Kelvin wave generation area ends about 170 west. So we're really only concerned about this area right here. The good news is we see piles of easterly anomalies up to today, and then significantly dropping off as we get into Monday the 18th, and slowly pushing off to the east with a neutral wind pattern setting up over the West Pacific over the next week. So that looks somewhat better. Not like the active phase, but more like neutral. So let's go out 2 weeks. Outgoing long wave radiation predictions, forecast. All right, that is fancy words for cloud cover. The active phase of the MJO is like a low pressure system that dampens trade winds. The inactive phase is like a high pressure system. We're looking here, this is data from the statistic model. There's South America, Central America, Hawaii, New Guinea. The dateline, 180 right there. The equator right there. Kelvin wave generation area right in this area. And we have these blues. What's the blue mean? More or less sunlight reflectivity off the ocean surface. Negative values means more cloud cover than normal. If you have more clouds, you can't get a lot of sunlight bouncing off the ocean surface. So one should say weekly the active phase, 5 days out, holding, and then we go dead neutral on days 10 and day 15. That's per the statistic model. The dynamic model says the same thing initially, but then more sunlight reflectivity off the ocean surface. That means less cloud cover. That'd be high pressure. That'd be the inactive phase of the MJO, possibly setting up, we'll say 10 days out and building 15 days out. So the two models are not in agreement. So we drill a little deeper. Phase diagrams. Okay, more detail on the MJO. So the heavy dot, I don't know if you can see it, is where the active phase is right now, the maritime continent. All right, and the MJO moves from west-east, from the maritime continent to the West Pacific to the East Pacific, under the United States, over the Atlantic, over Africa, into the Indian Ocean, and round it goes. So right there, the heavy dot is where the active phase is, roughly Bali. And the further away from this circle, the more further out here the dot is, the stronger the active phase is. So extremely weak, and just forecasting slowly pushing to the West Pacific, and weaker still 2 weeks from now. That per the statistic model. The dynamic model has the active phases green line racing off the whole way around the planet in the next 2 weeks and over the Indian Ocean, and again, exceedingly weak. So neither of these charts suggests any significant push for the jet stream or addition of energy to the jet stream from the MJO over the next 2 weeks. All right, the upper level model. And this indicates areas favorable for precipitation. The reds are the inactive phase of the MJO, dry air. The greens, wet air. And let's get ourselves oriented. There's 8 different frames here, the same background. South and Central, South America there, Central America, one little pixel of Hawaii, New Guinea there. 0 is the equator. The date line roughly there. The area we're interested in is right here. That's the Kelvin wave generation area. Right now, weak active phase over the Kelvin wave generation area, but you see quickly moving off to the east and into Central America on August 11th with the inactive phase building behind that on about August the 11th, and then it filling the Pacific Ocean through the end of August. So whatever support we have for gale development is right now, as we get deeper into July and early August, that support will fade, and then we'll be into more of a dry spell. Not unusual. Typically in the late July, August time frame, seems like it's always a downtime for southern hemi swells. All right, let's go out a month here. This is data from the GEFS model, and this goes out 1 month from July 16th to August 13th, roughly. All right, Kelvin wave generation area, same deal. This is the east-west component of the wind. The blues are easterly anomalies, the reds westerly anomalies. The black solid line here is the active phase of the MJO, and the Kelvin wave generation area starts right here in this box right here. So we see the active phase of the MJO building over the Kelvin wave generation area. These oranges here, westerly anomalies, forecast building out, this is a 1 week period, so out maybe over the next week to about 160, 165 west, not even making it to the date line, holding for a day or two, quickly backtracking, so a very weak active phase, not doing a whole lot. Then right behind that, easterly anomalies build and take over the whole way through August, pretty much pointing to what we saw in the previous charts. So if that doesn't look good, let's go out even further in the time, out 3 months. This is the 3-month CFS model, 850 millibar zonal wind anomalies. Another way of looking at it is blues, easterly anomalies, the inactive phase of the MJO, yellows and reds, westerly anomalies, the active phase of the MJO. All right, we're gonna, and just eyeballing it now, this is past performance here. This is the forecast up here. What we see is a big pile of easterly anomalies forecast, but they're not on the date line. They're west of the date line, centered maybe 150, 160 west, and westerly anomalies building and making progressively more progress into the Pacific to about 170 east as we get into the fall. That's pretty much a good sign. We really want to see the core of this shift more into the Kelvin wave generation area, but if we were to see that, that'd probably be a sign of a pending El Nino. We don't think that's going to happen anytime soon. All right, we're overlaying the MJO, the Madden Jullian Oscillation. This solid contour, active phase of the MJO. This is west moving east. So you see the active phase of the MJO making it into the Kelvin wave generation area, the date line right about there. So maybe the yellows, westerly anomalies over the next week or so, making it almost to the date line, then fading out. An inactive phase of the MJO sets up with easterly anomalies into about mid-August, something like that. Then after that, some interesting things happen. This model has been consistently showing the active phase of the MJO building, but just like lingering forever, like from the early part of August into at least mid-October over the Kelvin wave generation area. Now you'd think these westerly anomalies would push further into the West Pacific. They don't, but they do get traction to about now 165 east, something like that. Pretty good. Maybe this whole region right in here would be a good sweet spot for storm development. So we're looking at about the early part, pretty much the whole month of September and into early October, the beginning of fall. That would be a good thing. All right, now let's overlay the low pass filter. This is the high pressure, low pressure bias, the El Nino, La Nina indicator. The dotted contour here, and as we're looking past down here, this is the high pressure bias, the solid contour, the low pressure bias. Consider this like El Nino and this like La Nina. And then we look, well, the La Nina signal supposed to continue as we get into the fall with the El Nino, I said La Nina there, I hope, and the La Nina, or the El Nino indicator here, hanging over the maritime continent, trying to make the leading edge make some foray into the Pacific, but not really doing it. Interesting. Pretty much a steady state, according to this model. All right, so let's go take a look down into the ocean. Now we're getting to the El Nino, La Nina indicators. And what does the ocean think is going on? This is the West Pacific here. This is the East Pacific here. This data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. These are the anchor lines on those buoys. The X's are the sensors, temperature sensors on those anchor lines that go down 100 meters, 200 meters, 300 meters. The idea is you take the data from all these sensors, use a model to fill in the gaps, and you get a profile of what the subsurface ocean temperatures are doing. In the West Pacific, the 29-degree isotherm here is moving east to about 163 east. That's about like what it was last week. The 28-degree isotherm to about 176, 177 east. That's about where it was last week, maybe backtracking a degree or so. 26-degree isotherm at 130 west. That's where it was last week. And the 24-degree isotherm, a little bit shallower here in the west than it was last week, but still not too bad in all. But it's not the actual temperatures, the means, it is the anomalies, differences from normal for this time of year. We see warm water in the West Pacific, 2 degrees above normal, down about 150 meters. That's about what it typically is. Thin little stretch of warm water pushing off to the east, and then what appears to be a Kelvin wave erupting in the East Pacific with temperatures 3 degrees above normal. Now, this is one model's view of what's going on, but we look at another model here, and it's painting not quite as optimistic a picture. It says there's literally, you see the warm water in the west here, but there's literally a gap now, instead of a little finger of warm water, a gap of cool water in this area, and the last bits of the Kelvin wave erupting in the east and likely getting ready to fade out, with cool water re-emerging here in the central to western Pacific. Sea surface height data. That is, these are not temperatures, but they can be roughly equated to temperatures. It is the height of the ocean. Take the waves out, the wind waves out, the tides, and is the sphere of the ocean higher or lower than normal? If you have cold water at depth in the ocean, it contracts. It'll create a divot on the ocean surface. This satellite here will measure that. Likewise, if you have warm water at depth, it expands. It'll create a bump on the ocean surface. And again, the satellite here will catch that. So, what are we looking at? Chile, Peru, Central America, Hawaii, New Guinea there, the equator there, dateline there. And we're only interested in 5 degrees north and south of the equator over this entire region here. Clearly, warm water, positive anomalies here in the West Pacific. But we get to the dateline, the emergence of this negative -5 centimeter anomalies. It's not very deep, but that wasn't there 2 weeks ago. Instead, we had warm anomalies over this entire area, and there's the last little bit of the warm or positive sea height anomalies from 0 to 5 centimeters, suggesting the Kelvin wave is sort of cut off from the mothership back here. It's erupting. So there's Ecuador, the Galapagos there, Ecuador right in this area, erupting to the surface, but definitely on its last legs. Upper ocean heat anomalies. Let's put this all together. West Pacific here, East Pacific here. In time, December last year, Kelvin wave pushed across. Then we had a big upwelling event. The blues are colder than normal waters. The yellows, reds warmer than normal waters. Cold water erupted all spring. Trades nuked. Things were pretty miserable. Then we got this Kelvin wave that developed, tried in April. Another active phase of the MJO set up in the June time frame produced the Kelvin wave, warm water pushing across the Pacific. But you see it slowly fading out here, south of California to about the Galapagos, with cool water starting to again build. So you get upwelling warm water, cold water, but this is a bit exaggerated. Here we go, warm water again. Here comes the cool phase. Okay, but at least we're getting a semi-regular pattern of Kelvin waves and then cooling, suggesting maybe slowly working our way back towards the normal pattern. Upper ocean heat anomalies just graphed out, going back to, July of 2021. We got, and this is total heat volume between the area of the dateline and 100 west. A lot of cold water into last fall. We got our Kelvin wave in February, created a little peak. We went into the cold phase, but notice, not nearly as cold. In fact, you could almost draw a straight line right up here. Here's our current Kelvin wave fading out. We'll see how far down we go. We don't think we're going to go very far at all. And then we're going to head upward from there, we think. All right, let's go look at ocean surface temperatures. We know that there's a pattern down deep, but there's a different pattern at the surface. Let's get ourselves oriented. Chile, Peru, Central America, California up here, Hawaii there, equator roughly right there. There's the Galapagos. We see warm water over the Galapagos pushing out to almost a point south of Hawaii. This is the Kelvin wave that is erupting. It's erupting right there by the Galapagos. The trades take that warm water, catch it, start dragging it off to the west. But we still have this giant pool of cool water, certainly present on the date line, south of Hawaii and west of there, and off of Chile and Peru. There was a pocket of extreme upwelling in this area. That is all but gone now. But still, it's just this persistent cool water. Cool water doesn't support evaporation, doesn't support uplifting of moisture and energy into the atmosphere, which therefore doesn't support the jet stream or feeding energy to the jet stream. Instead, it supports high pressure development over the Pacific. So we have a little bit of warm water trying to organize, but it's only been here a couple of weeks. Takes a lot more than that, but still, any bit is better than being where we have been with La Nina just locked in place and in control. Sea surface temperature trend for the past 7 days. Well, here's these pockets of warming here. There's also a couple of little stray pockets of cooling off the Galapagos right there. So marginal warming from the Kelvin wave, but nothing significant, not enough to really activate the jet stream or anything. We're just trying to chisel away at La Nina, literally with a hand chisel, one step at a time. The backed off view, again, you see generalized broad area of cooling, not particularly deep or strong, but still definitely in place. Our Kelvin wave trying to create warming at the surface, making a dent in this large area of blue, but certainly not wiping it out. The sea surface temperature trend over the past 2 months or so. This is in the Nino 1.2 region. This is right there by Ecuador and the Galapagos. Temperatures today still below normal, minus 1.261 degrees below normal. The La Nina threshold is minus half a degree, so right there, we're way below that. But this isn't the official El Nino region. This is the Nino 3.4 area. This is the region from south of California out to about the dateline. Temperatures were trending upwards to about a quarter of a degree below normal, so this is above the La Nina threshold since about June 8th or something like that, but now starting on a downward trend. This is not unexpected. If you've been following these videos, we show you the models. We know there is another small downward trend coming. The question is, how far down is it going to be and how long is it going to last? But right now, still above La Nina threshold at 354 thousandths of a degree below normal. Pretty much what one would consider normal. So what does the atmosphere think is going on? I think one can pretty easily figure it out. We have a lot of blues, a lot of colder than normal water temperatures still in control. Warm water trying to chip out its place in the equatorial Pacific, but only weakly so. Anyway, so we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin in the Indian Ocean. If pressure is lower in Tahiti, the index goes negative, like it is today, minus 2.77, just barely. But you look down here, it's been positive for most of the entire month-long period. So clearly a preponderance of La Nina, or at least the inactive phase of the MJO conditions in control. 30-day average SOI, just average all this stuff out. Today's value, 12.79, but that is lower than, well, where we've been for a month. We've been in about the 15.5 range and even higher at times. So maybe things settling down a little bit. The 90-day average, this is the La Nina El Nino indicator. If this were negative, that would be really good. Still positive, 15.84, but less positive than it's been. We were up to 18. I think we were up at 19 at one point a couple of months, 2 months ago, something like that. So slowly settling down, but not clearly indicative of a trend towards even neutral, much less El Nino. We can graph out the 30-day SOI index to sort of see historically where we are. Last time we were in a semi-normal range was the spring of 2020, And then since then, you can see the index going steadily upward. The upward pushes are the inactive phase of the MJO. The downward pushes are the active phase of the MJO. The upward pushes are beating out the downward pushes. Clearly indicative, you can draw a line through this in your mind's eye. La Nina in control. Seems like we are peaked out. This was, what, about April, late April, peaked out somewhere around 23. Trying to work our way down. We really want to see this downward trend continue, and it's not much of a trend, but at least it's a little something. So what's the sea surface temperature supposed to do in the coming months? Data from the GEFS model version 2 for the Nino 3.4 region, the official El Nino monitoring region. This says today temperatures are a half a degree, 0.55 a degree below normal, the La Nina threshold right here, so still in the La Nina range. The other real data we looked at says we're actually up at 0.3, but the trend from here, as the current Kelvin wave erupts and dissipates, and the inactive phase sort of sets up temperature dropping to, according to this model, about 0.95 of a degree, and then dropping even further into October and early November down to minus 0.11 degrees. But then from November on, a steady rise upward, not only through the normal zone, but maybe getting the sense that we're pushing to somewhere higher than normal. Now, this is raw data. The corrected, sort of smoothed out, better rationalized model suggests, well, temperatures certainly are going to fade down to maybe only 3/4 of a degree just for about a month in November, and then again on an upward trend. The same model, looking at the actual sea surface temperatures, well, there's kind of where we are today. Semi-normal temperatures around the Galapagos and much colder. But let's see if we can just click through these. We're going to jump to October. Temperatures still holding, but not as dense and not as intense here south of the equator. And then when we get into December, look at this. According to this model, almost a completely neutral trend, and all that cold water is gone. And then as we get into, here we are, in January, maybe I can blow this up just a little bit here. There we go. As we get into January, a dead neutral temperature pattern, no El Nino, but no La Nina anymore. And this is in January. This is probably mid-January. If that's the case, and it's been getting progressively less cold, this suggests that comes, let's say, maybe November, something like that, the atmosphere will start sensing a change. And as we get into late January, early February, the atmosphere and the jet stream might have reconfigured itself enough to go, hey, we're back in a neutral pattern. Again, that means precipitation moving into California, better storm track, more winter storms as we get into the heart of winter. Maybe that's a bit too much to ask for, but at least it looks like we're headed in the right direction. So all the El Nino, La Nina stuff, MJO stuff aside, clearly there is large swell that has hit Hawaii, larger than any normal summer swell with a long period, and that swell is propagating towards the California coast. In fact, if you look at buoys down in Southern California, you can see 22 small but present 22-second energy already building there, and that is only expected to continue upwards for the next 2 days or so. So, large swell on the way. Make the most of it. Literally nothing is forecast behind for the next week. But the flip side of that is do not put yourself in danger. If you don't have the skills, find a protected break or give it a day or two and let the peak of the swell pass, and then surf when the size is more appropriate for your skill level. This will be an experts-only swell. In fact, if you have property on the ocean in the California coast, especially exposed south-facing breaks, do whatever you need to do to protect your property now. Hawaii definitely took a pounding. The larger sets with the long period certainly did impact coastal locations and property. All right, beyond that, probably not a lot of southern hemi swell, maybe some wind swell. Maybe we'll just need a break for a couple of days after that. Long term, the fall, still looking like a La Nina type fall situation, but as we get deeper into winter, then perhaps a return to normal, and hopefully some good precip for California as we get into the later part of winter, and maybe we'll eke out at least a normal amount of precipitation. All right, again, if you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Comments always welcome. You don't understand something, you know there's 10 other people that are thinking or have the same question you do. Write it in the comment section. We'll reply. Try to keep you all up to date. I might be a little slow on the replies for the next couple of days, and you could probably guess why. But after that, back to business as usual. All right, thanks for watching, and we will do this video again next week, same time, same channel. See you then.